Hi students, I just wanted to go over how to complete the Colligative Properties Lab. So when you click on this assignment, it will pop up and look like something like this page, and the video you are watching will be sitting right here. You are going to next click on the Salty Roads simulation. When you click on that, it will show something like this. Now, if for some reason it shows a truck driving and asks questions, just go ahead and click this side arrow until you see this image. So what you're going to be doing is you're going to run 6 different simulations. We are going to first start with just 1 mole of sodium chloride. So arrange that to 1 mole of sodium chloride, and then we're going to press play and see what happens. So it's going to drop down 1 big chunk of sodium chloride, and we're going to see what the water molecules start to do when they interact with sodium chloride. Now, as you're watching this, I want you to think about, are the water molecules moving faster, moving slower? Are the water molecules separating out from each other? Is the salt particles, are they separating out from each other? Are the purple and orange particles separating out from each other? Now, just a reminder, the red and white particles, these are water molecules. The purple and green, those are your salt. Now, you can see that the water starts to become more rigid. It's stuck in place and vibrating. This is water being frozen again. And we're going to keep letting this run until this timer right here goes to a stop. And when it finishes, it's going to put a dot on our graph. You will know that you are complete when there is a dot on the graph. Now this tells us that if I put 1 mole of sodium chloride, the water will need to be negative 3.75 degrees Celsius in order to freeze. So the water will need to be even colder than 0 to freeze. We are going to run this again, but add 2 moles of sodium chloride and do the same thing. And then you're going to do it again for 3 moles. Remember, don't stop it too early. Let it run its entire simulation. You are then going to do the same exact thing for calcium chloride. So I stopped the simulation when I clicked the other one, and you're going to do the same thing for calcium chloride. Add 1 mole of calcium chloride, run the simulation, add another mole the second one, run the entire simulation, then add the 3rd mole and run the entire simulation. So as you see here, the water was frozen at first, and then it starts to move around as it starts to interact with the calcium chloride. It's moving faster and faster and faster because it's melting because of the calcium chloride. Now if you look, all of the particles here are all moving faster because they have all been melted because the water is attracted to the salt, and that breaks up its bonds. Now, as the calcium chloride starts to sit on the bottom, these upper molecules of water will now become frozen again because there are no longer calcium chlorides restricting these bonds between the water. Once again, we're going to let it run until the simulation is complete, and a dot will be added to our graph again. Oh, there it is, a green little dot. So this is telling us if I add 1 mole of calcium chloride, it will freeze at negative 5.75 degrees Celsius. Okay, so like I said, you're going to have 6 dots on this graph by the end of this because you're going to run it for 1, 2, and 3 moles. You can use this graph to then complete the next set of questions on Canvas. So here are some basic instructions I just went over. You're going to run it for 1 mole of NaCl, 2 moles of NaCl, 3 moles, then 1 CaCl2 and on, okay? Now real quick, this document, this lab write-up, this is graded off of correct answers. So if you give me some answers that you just kind of made up, I'm not going to give you points for that, okay? So it is graded off correct answers. So you scroll down, you will see this. Now, if this doesn't pop up right away and it says to sign in with your CSD Docs account, okay? So here are some questions here you need to answer. You can either use this graph to answer the questions or the graph you just made on your simulation. And you're just going to type right in here your answer to your question. So here are my answers. Beautiful. And you're going to do that for each of them. There are 6 questions to answer. This last question is 2 points, and I do require 2 complete sentences to answer this question. You can use your notes. You can talk to your friends about this. You can message through Canvas students in our class and ask them questions about this, okay? Also, if it's not working for you, please, please, please email me and we can do a little Google Meet session and we can go over making sure it's working for you. Please let me know, okay? When this is all completed and you wrote this all up, you will have a blue submit button over here. I don't have it because I can't submit something I made. So you're going to have a blue submit button. You need to click that submit button because that is how you turn your work in. If you write it up and don't click it, I'm never going to see it and I'm going to think that you did nothing. Okay? So, quick review. Run the simulation, run it 6 times, watch and see what happens to the ice when we add salt to it. You'll see it break up, melt down, no longer become ice. Then it'll freeze up again as the salt sinks to the bottom. And then you are going 6 questions and then click the blue submit button. And that is your colligative lab properties. Let me know if you have any questions.